All right, this is a series question from 2018. They gave us the Maclaurin polynomial for the natural log of 1 plus x centered at 0. So you can see this is our Taylor polynomial. And part A, write the first 4 non-zero terms and general term for this. And then part B is find the interval of convergence. And then we'll come back and do part C. Part A wants you to, they've given you the Taylor polynomial for natural log, and it's centered at 0. And they want you to find the Taylor polynomial for this new one, and they want the first 4 terms, the non-zero terms, and the general term. And then part B, we want to find the interval of convergence of that. C says, let P4 be the 4th degree Taylor polynomial for f about x equals 0. Use the alternating series bound to find the upper bound for that value. Okay, so if we're using the P4 Taylor polynomial, that means we're looking at the 5th degree to talk about air, and we plugged in x equals 2. This is the 2018 Taylor polynomial. Okay, so looking at this, we know that the Taylor polynomial for natural log of 1 plus x is equal to that. So the first thing we're going to do is go through and replace all the x's with x over 3. So this will be x over 3 minus x over 3 squared over 2 plus x over 3 cubed over 3, and then minus x over 3 to the 4th over 4, and then our general term, x over 3 to the n over n. Now, I'm eventually going to have to use this, and we're going to be multiplying by another x. So if we're going to multiply by another x, that's going to change the power on the x, but not on the 3. And all the way through, that would change the power on the x, not on the 3. So the first thing I'm going to do is just kind of separate those powers. So this is the same thing as x over 3 minus x squared over 3 squared times 2. And then x cubed over 3 cubed times 3. X to the 4th over 3 to the 4th times 4. And then, of course, make sure that everything looks nice and consistent, because you can catch a lot of errors by just going back. So looking at this, I've got x squared, squared, and 2, cubed, cubed, and 3, 4, 4, and 4. So I see a lot of the same things. I see that it alternates. And the last thing they want me to do with this one is multiply it by x. So x, natural log of 1 plus x over 3, that is going to change only the powers on x. Every power of x goes up by 1. And of course, this looks bad, but when we add 1, all it does is change n, the power n on x, to n plus 1. And again, go back and make sure everything looks very consistent, because it's easy to make a mistake. Here we've got 4th power, 3rd power, 3, 5th power, 4th power times 4. And I don't think that meant to be a plus sign right there. That was definitely a little typo. That's supposed to be times 4. All right, so that's part A. And how was part A scored? You got 1 point for the first 4 non-zero terms, 1 point for the general term. All right, so the second part, it wants us to find the interval of convergence. Remember, for the interval of convergence, you have to use the general term. So remember, the interval of convergence was the limit as n goes to infinity of an plus 1 over an. So immediately we're going to multiply by the replacing n's with n plus 1. Now we multiply by the reciprocal of an. Now we cancel everything we possibly can. The alternating means nothing inside the absolute values. Looking at the geometric type piece, I've got an extra 3 on the bottom and an extra x on top. After that point, we ask ourselves, are the degrees equal? And you can see right here, the degrees are equal. So it's just the ratio of the leading coefficients. So we're left with the absolute value of x on the top, 3 on the bottom. For convergence, this needs to be less than 1, which means the radius is 3. Now we have to check our endpoints. Remember, it was centered at 0, so we're going to go 3 to the left and check x equals -3. And we're going to go 3 to the right and check x equals +3. And when we check that, we're going back to this general term here and plugging it in for x. So we have -1 to the n plus 1, -3 to the n plus 1, 3 to the n times n. The first thing you should notice is that these should cancel in absolute value. Whatever was here should be the same type of geometric piece. So this right here we know is harmonic because p is equal to 1. So it matters if it alternates, and this will not alternate. They'll either both be positive or both be negative. So this is divergent. So at -3, we do not include it. At 3, when we plug that one in, you can see that now this is a p equals 1, and it's going to end up alternating because these are just going to be off by 3. So that will converge. And then lastly, part D. And notice this is an alternating series. So we can say for a convergent alternating series, the error is less than the first omitted term. We did degree 4, so we're looking at degree 5 for our error. So our error is going to be less than plugging in 2, so 2 to the 5th, 3 to the 4th times 4. Now remember, this is because for a convergent alternating series, the error is less than the first omitted term. Degree 4 approximation. Degree 5 is error. And we plugged in x is equal to 2. So this would be the smallest error possible. So this would be 32 over 3 to the 4th times 4. And I think that works out to be 8 over 81. So how was this one scored? We already talked about part A was worth 2 points, one for the general term and one for the first 4 terms. The next one, the interval of convergence, this is going to be worth 5 points. One for finding the ratio, one for finding the limit, one for finding the radius of convergence, one for checking both endpoints, and one for getting both endpoints correct. And this one, you're going to get 1 point for using the 5th degree and 1 term for saying that.